Hi all, welcome to Heights to Fly. Today we are discussing about number systems. Number systems we can categorize it into four: integers, natural numbers, whole numbers, and the fourth one, rational numbers. Integers, whole numbers, natural numbers, whole numbers, rational numbers. Before going to this categorization and details, let's discuss about number line. A number line is a line which consists of all types of numbers, and we can divide a number line into 2 by 0. Right to the 0, it is positive numbers. Here, negative numbers. Zero, positive numbers. In this direction, positive numbers are marked, and in this direction, negative numbers are marked. These are the numbers present in number system. Then integers. Integers are numbers which consist of all numbers in number line. That now we represented numbers: -3, -4, -2, -1, 0, 1, 2, 3, etc. Integers are represented using variable z or representation z, and z consists of numbers, all negative numbers, 0, then positive numbers. These are integer category numbers. Natural numbers are represented by n, and it consists of all natural numbers like 1, 2, 3, 4, etc. Whole numbers are represented by alphabet W. It consists of numbers 0, 1, 2, 3, etc. That is natural numbers plus an additional 0, 0, 1, 2, 3, etc. And the fourth one, which is the main topic, rational numbers are numbers which are represented in the form P by Q. Rational numbers are also known as fractions. It is represented in variable R. P by Q. Rational numbers are represented in the form of P by Q, where P and Q are integers. That means it can take value 0, 1, 2, 3 and negative numbers also. But the value of Q should not be equal to 0. The value of Q should not be equal to 0. That is, we can represent P by Q as 3 by 2 or 2 by 3, -2 by 3, etc. But we can't write a rational number as 2 by 0 because it is an invalid number. Division by 0 is an invalid operation. Any number we can't divide it by 0. It is an invalid operation. Okay, but 0 by 1 or 0 by 3, division by any other number to 0 is possible. This is okay. The value is 0. 0 divided by any integer results into 0. So we discussed about integers, natural numbers, whole numbers and rational numbers. Integers are represented by variable z. It consists of all negative numbers 0 and 1, natural numbers n, which consists of all positive numbers, whole numbers w, 0 and all positive numbers, rational numbers or fractions represented by variable r, which are represented in the form of P by Q, where P by Q are integers, but with one condition, q not equal to 0. Examples are 3 by 2, 2 by 3, minus 2 by 3, etc. But 0 by 1 and 0 by 3 or 0 divided by any other integer is equal to 0. But any integer divided by 0 is not a valid operation. We can represent numbers, rational numbers in number line as if we have to represent 1 by 2. 1 by 2 means 0.5. Here it is 1 by 2. In this method, fractions or rational numbers are representing. Here it is 1 by 4. Again 1 by 4 we can represent it here. 1 by 4. Like that. Okay. Next to go to an example in the question, in the textbook. Example 1. We have to discuss about every whole number. Every whole number is a natural number. Is a natural number. Every whole number is a natural number is a statement given in the textbook. We have to state whether it is true or false. Is it correct or not? Every whole number is a natural number. It is actually false because 0 is not a natural number. All others numbers are present here, but 0 is not present in natural number set. So we can say that this is a false statement because 0 is not a natural number. Because 0 is not a natural number. And the second statement is every integer is a rational number. Every integer is a rational number. Is it true or false? Every integer means all negative numbers, 0 and positive numbers. Every integer is a rational number. It is true because we have values like minus 2, 0, 2, 3, etc. in the integer category set. But we can represent it as a ratio also because minus 2 by 1, 0 by 1, 2 by 1, 3 by 1, like that. That is, every integer can be represented in a rational form. So we can say that the statement is true. Next statement given is every rational number is an integer. Rational number means fractions like 2 by 3, 3 by 2, 5 by 6. Is it a rational integer? Is it an integer? No. These are not integers. These are simply fractions or rational numbers. So we can say that this is a false statement because 2 by 3 is not an integer. Here we discussed about 3 statements. Whole number is a natural number, which is false. We say that why it is a false. Every integer is a rational number. It is true. Every rational number is an integer. It is also false. We go to the next example discussed in the textbook. Example number 2. Find 5 rational numbers between 1 and 2. Find 5 rational numbers between 1 and 2. There are 2 methods to find a rational number between 2 values. We discuss first method. First method we are discussing. To find out rational number between 2 numbers, here the values given are 1 and 2. Take it as A and B. We have to do A plus B the whole divided by 2. That is 1 plus 2 divided by 2, the resulting value is 3 by 2. So the sequence becomes 1, 3 by 2 is a value lies between 1 and 2. So we can write it as 1, 3 by 2, 2. Next we take this as A and this as B. So 1 plus 3 by 2 is equal to the whole divided by 2. You have to take the LCM in the numerator position. And 1 into 2 plus 3 by 2 into 2. Take 2 as LCM. So the denominator becomes 2. Then have to multiply this 2 using 2 by each terms. So 1 into 2 plus 3 by 2 into 2, and this denominator 2, which is equal to 1 into 2, 2 plus 3 by 2 into 2 is equal to 3. 2 into 2 is equal to 4, which is equal to 5 by 4. 5 by 4. So we can write the sequence again as 1, 5 by 2, 3 by 2, 2, because we write 5 by 4, 5 by 4, sorry, 5 by 4. We write 5 by 4 here because we take 1 and 3 by 2 as A and B. So 5 by 4 lies between 1 and 3 by 2. This is the middle value of 1 and 3 by 2. Next, we are going to another intermediate value considering A and B as this 3 by 2 and 4. 3 by 2 plus 2 divided by 2. Here the LCM is 2 itself. 3 by 2 into 2 plus 2 into 2. The whole divided by 2. 3 by 2 into 2, 3, 4, 2 into 2, 4. The whole divided by 2 into 2, 4. It is equal to 7 by 4. So we can rewrite the expression as 1, 5 by 4, 3 by 2, then 7 by 4, then 2. So again, we can take another intermediate value. This is A and B. So 5 by 4 plus 3 by 2, the whole divided by 2. Here the LCM is 4, LCM of 4 and 2. 1, 2 into 2 into 1. So the LCM is 4, 2 into 2 into 1. So the LCM is 4. 5 by 4 into 4 plus 3 by 2 into 4. The whole divided by 2. 5 by 4 into 4 is equal to 5 plus 3 by 2 into 4 is equal to 6. The whole divided by 8. So 11 by 8. So we can rewrite the intermediate values as 1, 5 by 4, current value 11 by 4, next value 3 by 2, 7 by 4, and last one 2. And we have to find out 4 intermediate values, and the last one we are going to the last intermediate value 3 by 2. This one as A and this one as B. So 3 by 2 plus 7 by 4, the whole divided by 2. Here the LCM is 4. So 3 by 2 into 4 plus 7 by 4 into 4, the whole divided by 2. So we can write it as 3 by 2 into 4 is equal to 6 plus 7 by 4 into 4 is equal to 7. The whole divided by 8, which is equal to 13 divided by 8. So the intermediate values are the rational numbers between 1 and 2, 3, 5 by 4, 11 by 4. Sorry, is it 11 by 4 or 11 by 8? Sorry, 11 by 8. Here the value is 11 by 8. Then 3 by 2. Then 3 by 2. Then 13 by 8. 7 by 4 and 2. These are the 5 rational numbers. 5 by 4, 11 by 8, 3 by 2, 13 by 8, 7 by 4. We find out all these values by using the expression a plus b divided by 2. That is, the two values are taken as a and b, and the sum of this taken and it will be divided by 2. And the next question or the next example, for the above question, there is another solution. The second solution was the second method. We have to find out 5 rational numbers between 1 and 2. So take this value as r, small r. We have to take r plus 1. 5 plus 1 is equal to 6. So represent 1 in the form of 6, that is 6 by 6, which is equal to 1. Multiply numerator and denominator of the value by 1. So we get it as 6 by 6. Again, the second value also, the second value 2 is also do like that. 2 into 6 divided by 6, which is equal to 12 divided by 6. So the numbers, again we can represent it as 6 by 6 and 12 by 6. We can represent the rational numbers in the form, the first value is 6 by 6, second value is 7 by 6, third is 8 by 6, 9 by 6, 10 by 6, 11 by 6 and 12 by 6. Numerator values are changed. These are the values or rational numbers in between 1 and 2. This is the result. Again, now to represent 5 rational numbers between 1 and 2, we take this value as r. Then we take r plus 1, which is equal to 6. We represent this the two values in the form of r. We multiply the numerator and denominator by 6. We get a rational number 6 by 6, and the second case 12 by 6. In between this, we can find values like 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. This is a simpler method compared to the previous one. So we can follow this method for further examples. So today we discussed about a number line. What are the different types of number systems present in mathematics? 4 types are there. Then we go through more detail about rational numbers, how to find out rational numbers between two values, like that. On next class, we will discuss about exercises or problems relating to this fundamentals. Thank you. Thank you for watching. Subscribe and share for new videos.